Welcome to AcuAir Training by Frick, a division of Johnson Controls. I'm Don Faust and I'm the training manager for the Garland Center at Frick. Our lesson today is on ultraviolet radiation and how it can benefit AcuAir users. You see, there have been some advances in UV technology. We can now operate UV bulbs in cold environments, and our UV bulbs are now washdown capable. This allows us to offer our end users airstream disinfection. Now, filters, especially HEPA filters, are capable of capturing most contaminant particles, including biological organisms. And filters remain an important safeguard against contamination. However, viruses are so small that they cannot be reliably captured by filters. And that's where UVC radiation comes in. We now have options for both our new units and retrofit kits for existing units. But first, let's take a look at how ultraviolet radiation works to control biologicals. The sun emits an entire spectrum of wave energy towards Earth. We're going to look at the mid-range of emissions, which has visible light at the upper frequencies and X-rays at the lower frequencies. Sandwiched in between these two spectrums are the UV, or ultraviolet band of emissions. They're UVA, UVB, and UVC. All three of these ultraviolet bands travel to the Earth. However, they don't all make it to the Earth's surface. The atmosphere around Earth protects us from the lower frequency UV rays. Now, UVA, which is high frequency, which causes our skin to tan, well, that makes it through the atmosphere. And UVB, those rays that cause our skin to burn, well, those get partially deflected by the atmosphere. And UVC, the type of UV light we use to disinfect, well, that gets completely blocked by our atmosphere. Most of us are familiar with the harmful effects of UV energy transmitted by sunlight in the UVA and UVB wavelengths, giving rise to ultraviolet sunburn inhibitors or suntan lotions. And we're also familiar with products engineered to withstand the effects of UV radiation, such as plastics, paints, and rubbers. However, unlike the UVA and UVB wavelengths, the UVC band has more than twice the electron volt energy as UVA. And it is well absorbed, not reflected by organic substances, adding to its destructiveness. This power allows UVC to break through an organism on a cellular level, effectively scrambling its DNA. Using UV lighting for coil cleaning has been an HVAC industry standard for many years. This technology is what was adapted to our market many years ago and what we have been offering. See, when air condenses on the coil, it gathers whatever contaminants are attached to the water molecules, and if this is left unchecked, it causes the coil to become clogged. This clogged coil hurts the performance of the system and makes the system itself less hygienic. Now, the theory is that UVC light is directed onto the coil surfaces, and this will prevent microorganisms from growing on those surfaces. It requires less energy to deactivate microorganisms on the surface of the unit, thus making it a very cost-effective option. However, only the air that touches the surfaces of the coil hit with the light will be disinfected. So there's a 1/8 to 1/3 inch gap between the fins on these coils where the air will pass through. So it's not going to be good at airstream disinfection. So using UV to clean coils is great, but with recent advances we can now do much more. The advances I'm speaking of are the relative costs of the bulbs. It's dropped, making them a much more attractive option. And the bulbs can now operate in a food processing environment. They can take the temperatures and they can be washed down. So the technology is there for us to be able to do airstream disinfection. With the focus these days on airborne disease, there are some significant benefits to airstream disinfection. The idea is that UVC light is within the airstream, and as air passes through the plenum, the UVC light deactivates microorganisms from reproducing. This requires more energy to kill the bugs while in the air versus simply surface cleaning. The mixed air units are a perfect fit for this kind of system. As the air passes over the UV bulbs multiple times, more and more microorganisms are removed. This will continually clean the air as it moves through the space. Now, the effectiveness of UV disinfection is largely the result of three variables: intensity, exposure time, and air changes. The high number of air changes in our industry versus the HVAC world allows us to properly balance the lighting system and the performance effects these lights can cause. It's good to note that having room in the unit helps this style of system. The retrofit performance is based on a 40-inch spacing downstream of the cooling coil, which is pretty close to standard for our mixed air units. But just how effective can UV airstream disinfection be? Well, there's a measure called first pass kill rate. Literally, the percentage of organisms passing through that are rendered inert in one pass. Since different pathogens react differently, the measure is standardized for influenza A. Frick has two options for disinfection: 45% first pass kill or 60% first pass kill. Recognize that in our applications there are relatively high air changes, so the overall number of pathogens will continue to fall rapidly with either of these options. Also note that coronavirus is easier to render inert than influenza A. Next, we look at some operational parameters that users should be aware of. In terms of operation, the UVC bulbs are rated down to 30 degrees Fahrenheit, which means our plenum temperatures would typically not be a problem. UVC should only operate during the process mode, and the bulbs will require annual replacement, approximately every 8,000 to 9,000 hours. And as we stated before, the more the air circulates, the cleaner it gets. Here's a model of the interior of an AcuAir unit. The UV bulbs mount between the fan and the evaporator. The standard Frick AcuAir design allows for enough room, about 40 inches, to be able to properly position the bulbs. Now, this option is available for either new units or as a retrofit to an existing unit. With new units, the entire system is factory assembled. The stainless steel struts, bulb attachments, and hardware all come with the unit. It is control and power wired at the factory. The purchaser can choose to do coil cleaning, airstream disinfection, or both. But you must choose which level of disinfection you want, 45 or 60%. Now for retrofits, obviously, well, there's some assembly required. The bulbs and all necessary hardware are included, and 120-volt power wiring must be supplied as well. Now retrofits can do airstream disinfection at either the 45% or the 60% rate, but coil cleaning is not an option. In either case, the quantum panel will handle the logic and user interface for control. UVC's effects on the human body vary depending on the length of exposure, but it can cause painful burns on the skin. It can also cause temporary damage to the cornea if observed directly. Most cases of corneal damage clear up within a week, but are very painful. And aside from these threats, UVC is a known carcinogen for human skin. To assess the safety, each plant will have to assess the safety implications of implementing a UVC disinfection system. OSHA lists 3 levels of safety indications. Danger means that it will cause death or serious injury. Warning means it can cause death or serious injury. And caution indicates that it may cause minor or moderate injury. Many agree that UVC is a caution, but your plant may have different guidelines. One bit of good news here is that UVC is relatively easy to protect against. Tightly knit clothing, no skin exposed, and UV reflective goggles are typical examples of UV PPE. And there are some industry best practices we can look to for guidance. It's important to follow common sense safety strategy when dealing with UVC lamps. Many HVAC and UVC equipment manufacturers have voluntarily implemented safeguards against the risks of UVC exposure. Instructions and signage advise service personnel that the UV system should be turned off before performing any work in the air handling unit. Now, some of the safeguards include placing caution or warning labels near all access panels or doors to a plenum containing UV lamps, as well as on panels or doors adjacent to AHU sections where UV radiation may penetrate or be reflected. Install electrical disconnect devices on AHU lamp sections so that the opening of any access point de-energizes the UVC system. You may include door safety switches or a lockout-tagout feature to keep the AHU closed until the UV lamp power has been disconnected. These safety devices should never be overridden. And one of my favorites, training of service personnel. Train them to never look directly at UVC without adequate eye protection. Now, one possibility is to install a viewport, as it will block the UVC bandwidth. Ensure that the viewport is constructed from UL-classified fire-resistant wired glass and is sized and located to allow an operating UV system to be viewed from outside of the refrigeration equipment. Include proper safety signage to form a complete viewport signage assembly. And make it a policy to never enter the plenum when UVC lights are active. If it's absolutely necessary, suit up in personal protective equipment, including UV safety goggles, face shields, long-sleeve, tightly woven clothing that covers all of the body, and gloves. These safety precautions will help ensure service personnel are protected from accidental exposure while maintaining the effectiveness of UVC to eradicate biological contaminants. UVC is a great way to disinfect airstreams, resulting in fewer airborne pathogens affecting employees and the food they manufacture. Mixed air hygienic air handlers are an opportunity to employ this technique safely, without much risk of employee exposure. Contact your Frick Factor or regional sales manager for more details. Thanks for watching. We have more great training videos waiting for you at fricktraining.com.